It is my great pleasure to introduce Karl Müller. We'll be talking about the new cybernetics, an emerging post-disciplinary field from 1997 to 2001. Dr. Müller was head of the departments of political science and sociology at the Institute for Advanced Studies in Vienna. Until 2014, he was head of WISDOM, Austria's Infrastructural Center for Social Sciences, and the president of the Heinz von Förster Society. He is now the director of the Steinbeis Transfer Center, New Cybernetics, Vienna, Austria, and a professor at the University of Ljubljana, Slovenia. His main research interests range from complex modeling within the social sciences, from interdisciplinary analyses of innovation processes in science, technology, and economy, to the history and the current potential of inter- and transdisciplinary research, to the frontiers of second-order cybernetics and radical constructivism, or the newly emerging risk potentials for contemporary societies in general. And I will now turn it over to Dr. Müller. Thank you.
Thank you, Grant. This lecture may seem to you a little bit exotic because normally there were 4 people mainly associated with the American Society for Cybernetics. This was Reinhold Glanville, Stuart Umpleby, Lou Kaufman, and myself, and we presented our talks in some order. So one talk came natural after the other, and this time all 3 of the group of 4 is missing for different reasons. Stuart Umpleby is retiring from George Washington University and preparing for the 50th anniversary conference of the American Society for Cybernetics in Washington. Lou Kaufman is traveling around conferences worldwide and missed this one this year, this conference, and very sad for all of you who knew Reinhold Glanville. He was diagnosed with cancer, and he had 3 primary cancers and a rather short lifespan and life expectancy, and his presentations belonged, in my view, to the most interesting, and there were the peaks in this conference, but unfortunately Stuart also couldn't make it. So I'm the only one to talk about something about new cybernetics or second-order cybernetics, and I would like to show you some general outline of what you are going to hear. There are basically 4 points. The first one is about the mystery of second-order cybernetics, and it says a Copernican Revolution without traces, which is strange because especially Copernican revolutions should have strong traces and not left without traces. I would like to provide you with some frames which could be useful. The first one is about science levels or different science domains, and the second one is this notion of post-disciplinarity. We have now interdisciplinarity, multidisciplinarity, transdisciplinarity, and now it's post-disciplinarity. And I would like to tell you a little bit about what this post-disciplinarity means and why it can be distinguished from the other 3 versions of bringing disciplines together. Now, then the main part is new cybernetics as a Copernican revolution with 3 major building blocks or 3 major inversions, which can be qualified as Copernican inversions altogether, and then something which might be interesting to you as university people and deans or so on. There can be clusters of different PhD programs in new cybernetics, and I would like to introduce to you some of them. So that's an overview, and if you hear something about PhD programs, you know it's going to end, and then you can wake up and look forward to Thomas as the second presenter. So the mystery of second-order cybernetics, this is Heinz von Förster, and being president of the Heinz von Förster Society, that's an important, very, very important person to me. But he had made something very strange. He introduced this term, second-order cybernetics, and this term is somehow popular and vaguely someone associates with second-order cybernetics, with observers or self-reflexivity and so on. And he said explicitly, second-order cybernetics, that's a scientific revolution, and that's a Copernican revolution, as fundamental for the science system as a whole as Copernican revolution was for astronomy in the 16th century. So but Heinz von Förster only left one book, which was hopeful in terms of that it can provide a lot of material. It was called Cybernetics of Cybernetics. It was a product of his class in '74 at the University of Illinois in Urbana-Champaign, and then the class put together a really fascinating volume. It's still very, very interesting to read in terms of system science, cybernetics, and so on. And it's called Cybernetics of Cybernetics, so you would expect a lot of Cybernetics of Cybernetics in the book. But actually, despite its 500 pages, there are only there's only a two-page article by Stuart Umpleby on making a revolution based on cybernetics, which could qualify as having something to do with cybernetics of cybernetics. And on the front page, it made a definition and said cybernetics, first-order cybernetics is the cybernetics of systems observed, and second-order cybernetics is the cybernetics of observing systems. So you have the definition, you have a 500-page book, you have a two-page article on making a revolution, and you have no other clues and hints on what second-order cybernetics could mean. And Heinz von Förster himself, he was very, very productive until the late 1990s in terms of scientific articles and so on. He only produced a single article called Cybernetics of Cybernetics, 4 pages, and this article can be found in the book, posthumous book, Understanding, which was published 2003. So, but these 4 pages are the only pages where Heinz von Förster explicitly talked about this Copernican revolution and about what second-order cybernetics is. And he made a reference that it's a Copernican revolution and that it will be an alternative to the scientific method as we knew it, and it will revolutionize this. But aside from that, nothing is left. Nothing more was written and specified. So we have this mystery of second-order cybernetics. And what I'm going to present to you is a personal solution of this mystery. And I'm not claiming that this is what Heinz von Förster had in mind when he was talking about second-order cybernetics. This is something which I propose to you as some sort of new field called new cybernetics, or I could call it also second-order cybernetics. That's in this sense equivalent. So it's new cybernetics, and with some elements which qualify as some sort of Copernican inversions or Copernican revolutions. So before I come to this, here's a mantra which I used over the years central elements of Heinz von Förster's second-order cybernetics, where laws of form played, George Spencer Brown and laws of form played a central role. This LF here in the center, and NM means non-trivial machines, and I could go through these various building blocks, but from all the writings of Förster, second-order cybernetics was still some sort of transdisciplinary program, which, with a big difference that the OI means observer inclusion, that the observer, that the scientist, that the researcher should be part of the research process himself. This was one of the elements which clearly could be found in other writings of Förster. Now, I want to come to the term post-disciplinary configuration, and first, before I introduce this, I would like to introduce another frame which has become very useful for me, and that's a differentiation of the science system or science landscapes in either 3 levels, or if you like to put it in a horizontal way, in 3 domains. So if you think, so both versions are equivalent. You can think vertically, then it's 3 levels. You can think horizontally, then you have 3 different domains. And these domains are separated functionally. Going to this vertical separation, the reference domain of what we know about, what we usually characterize as science, is this first order level. That's normal science. That's science as we know it and as we practice it. Then there's over the last decades and so on, more and more important zero-order level, and that's the level of research infrastructures. This level hasn't been there, let's say, around 1850 or around 1900. It's being built now over the last decades, and it constitutes a special level which produces measurements, data, information, and so on for first-order science. So, this level of research infrastructure I qualify as zero-order level. So it's below the first-order level and provides measurements, provides important data, provides necessary data which are used for normal science and for first-order science. And then there's the second-order level, or what's usually called the meta level. It's when you talk about the first-order level, then you are at the second-order level. So it's this reflexive level where you talk about first order level, you are at the second order level. And as I said, you can put it either in a horizontal fashion or in a vertical one. And just to instantiate it a little bit with the world of science in the 1950s and the 60s, we had at the first order level the emerging big science, especially in the United States and Europe. We had the first decades of large-scale research infrastructure. So, for example, CERN was built in Switzerland at the end of the 50s, and other big facilities, especially for natural science and physics, were built around that time. So we had this instantiated large-scale research infrastructure, the zero-order level, and we had philosophy of science as an important field at the second order level. And this philosophy of science at that time, especially in the 50s and 60s, provided a lot of very interesting general information about theory building, descriptions, what definitions are, what explanations are, and so on and so forth. So what I mean now by the term post-disciplinary configuration is the one where you have the first science level with all the science fields, like here was a partitioning in 6 areas, like social sciences, humanities, medical sciences, technical sciences, natural sciences, and so on. So you have this first order level, and you have at the same time the second order level. And if you operate on both levels with inputs from all sorts of major science fields at the first order level. This is something which I would call the post-disciplinary configuration. So it's transdisciplinarity would mean to have some sort of common theory structures which you can apply across many areas at the first order level, for example, game theory or master equations and so on. These are models which can be used in a lot of different areas at the first order level, and this would be a transdisciplinary configuration. But if you have, if you operate at two different levels and with inputs from first order science in many fields and so on, this would I would call the post-disciplinary configuration. So this is just a suggestion. You don't have to accept it. So. Now I come to the most important point of my talk, and that's the only. There's only one point.
Why post-disciplinary and not to use the word non-disciplinary?
Naturally, because you like the word post-disciplinary in my suggestions for a talk, and it has something, you could also qualify philosophy of science as some sort of post-disciplinary discipline, especially in the 50s and 60s when it was really blooming, not in the later decades. But in the 50s and 60s, it's...
because it uses the disciplines. It's not in the disciplines, but it depends on.
Yeah, and takes inputs, and in the later decades, philosophy of science lost its contact to this first order science and became some sort of independent discipline. And so I think one can make sense of this notion of post-disciplinarity. Now I come to the most important point, and this is the first Copernican revolution or inversion for new cybernetics, and this is new cybernetics plays on a new domain, which I like to call, which is this second order level, and it's based on a very specific operation, and this is operation of re-entries. You find this notion of re-entries in the work of George Spencer Brown, and re-entries is if something, an unspecified domain X, enters into its own domain again. So it becomes, you see this operation graphically below. This domain X becomes X of X. So Luke Kaufman talks about these re-entries as a computation of computation, cybernetics of cybernetics, geometry of geometry, linguistics of linguistics, logic of logic, magic of magic, mathematics of mathematics, pattern of pattern, teaching of teaching, will of will.
Actually, there's an interesting point there. What you're doing there is simple recursion. Mutual recursion may be much more interesting. The mathematics of the philosophy of mathematics.
Thomas, you can make then all sorts of recombination once this point is accepted. And the point is not that this is a game to play, and that's an interesting intellectual pastime and so on. So my point is that this re-entry operation opens up a vast and largely unexplored science territory at the second order level. And you can gain very new and innovative insights by performing these re-entries. I'll give you one concrete example. I mean, I'm basically a social scientist background, but we are doing now a project at the University of Ljubljana with there's a very big European social survey. And this is conducted 2 years, and now we have already 7 waves of the European social survey. And this is also, all the articles written with this data set are first order level. What we did was to produce a database of all the articles which used data from the European Social Survey, and we are performing now an ESS analysis of ESS analysis, so a re-entry operation, and this provides us with enormous new insights on the status of the social sciences in Europe, because there are roughly 3,000 articles written with ESS data, and it says, and by doing this re-entry and making an analysis of all these ESS analysis, we were able, or we are able to show that, for example, of these huge data sets, only roughly 10% of the data set is used. 90% are not used by European researchers. There's a convergence of themes. There are 2 or 3 themes which are analyzed again and again. And there are a lot of themes which could be analyzed, which are not analyzed. One can make a reference to different nations. One can see that the social sciences in Scandinavia, simply by looking at the quantity of publications and so on, are very well developed, likewise UK. And in Eastern Europe and so on, it's relatively poorly developed status and so on. So you get all sorts of insights by doing this type of second-order analysis of available first-order analysis with ESS data, and and the same point can be made for all sorts of other types of re-entries, and re-entries can be performed in basically 2 ways. The upper way comes close to what's known as meta-analysis. I have more or less at the first order level, I have all sorts of analysis within a small field, and I perform a meta-analysis, or I can take inputs from very different fields and perform a re-entry here, and this is also closer to this post-disciplinary configuration. Here's a special page for Grandin, and I promised him to show something about the differences about second-order science, Science 2, and Science 2.0, because these are words which are floating around, and they look very similar or equivalent and so on, and I think one can establish clearly the differences between them. The distinction between Science 1 and Science 2 is one of historical phases or stages. So Science 1 is modern science from the 16th century up to the period of 1900 and 1950. So this is this period with a specific cognitive architecture of science, where universal laws played a predominant role, where theoretical physics was dominant, and so on. And from 1950 onwards, we have a new architecture of science where the life science become dominant versus theoretical physics, which is focused not so much on universal laws, but on patterns. And I mean, over the last years, I provided on several occasions, I made this distinction between Science 1 and... So this is a differentiation in stages. So everything before 1950 or so is Science 1, and has a specific cognitive architecture. From 1950 onwards, it's Science 2, and then as becoming more and more dominant. Now, Science 2.0 is a new support infrastructure which is available through the web, a new way of cooperating with which is not dependent on face-to-face communication, but you can communicate online with all sorts of social media and web-based tools and so on. That's Science 2.0 as a new, within Science 2, a new way, new additional support for cooperation based on all these tools and social media and so on, which are available. And second-order science is now an emerging, in my view, an emerging field for within the stage of science 2 again, where science deals with its own products, through these re-entries. And an interesting systematic argument can be made: the more science evolves, the more products it creates, the more you see something which can be called an inversion of novelty. I'll give you a practical example. If you make an evaluation of a university or of an academy of science for the 10th time, the cognitive content of the 10th evaluation will differ in minimal version from the other previous 9 ones. But a study on all the previous 9 evaluations, so performing this re-entry will produce a lot of new insights on the institution and also on the relations between this institution and societal phenomenon. I'm now moved beyond my time, or I'm. Najib told me. Najib told me that I'm a co-chair, but so I'm especially strict with myself. So I will be now very short with respect to the second and third element. The second element of this new cybernetics is, and here I would like only to introduce the term, it operates in a mode of endoscience. And I would like to introduce the terms exoscience and endoscience. And exoscience is science as we usually did it, exploring the world, describing the world, explaining the world, and so on, without the person who actually made these observations or descriptions or explanations. So without the observer. So it's observer-free. Exoscience is traditional science, observer-free under the rule of objectivity. Endoscience is you create, you make a description of a field including yourself as part of the field. And there are some areas in the social sciences, especially in qualitative methods, which can be qualified as endoscience. And what I don't have the time, but the basic argument is that new cybernetics plays also on this endoscience field. And the third point is that if you are yourself part of the field and part of the description and so on, we need new basic goals for in science, and we cannot come up with objectivity, because it's you as subject being there, being part of it. And what I would suggest here is that to intersubjective and intercultural reproducibility, you have to produce, or to what you produce in terms of descriptions, explanations, predictions, and so on, should be reproducible by others. And in order to be reproducible, you should provide an account of which comes close to a recipe of what you did in order to come up with your article, with your presentation, and so on. And that's the third point. And all three elements together constitute what I call new cybernetics. Something which might interest some of you is there can be a lot of PhD programs developed in the context of new cybernetics, and it's not only one single program, but if you can separate the science landscape, which I characterized at the beginning, in various dimensions. For example, you can use a dimension which says I separate it into empirical and normative sciences, or I separate it into social sciences, humanities, medical science, technical sciences, natural sciences, and so on. So there are all sorts of dimensions which can be used to separate science landscapes. And my point is that you can develop, and this is now for the European context, you can develop a 3-year program in new cybernetics for all of these partitioning. So you could produce a program in new cybernetics for the social sciences, new cybernetic PhD program for the medical sciences, natural sciences, depending on this partitioning into fields. You could, a very interesting partitioning could be between observer and processes, and program on scientific observers and so on. So what I would like to point out is that there's many possible PhD programs which could be constructed, and they, in the European Bologna process level 3 thing, it would require 12 field-specific courses and 9 PhD-related courses. And the fields can be variable depending on the dimension you use and depending on the context you want to establish, but it could be for the social sciences, as I said, or natural sciences, or empirical sciences, or normative sciences, or you could create a field like logic, mathematics, and so on. With respect to field courses, there's a specific distribution of courses. So it's basically 6 general courses, 6 special courses, and there's within the book which I'm going to publish soon, it's called New Cybernetics. There's a chapter on PhD curricula and with specific recipes and so on. At the end, by the way, kind of what I forgot, one important point, you are one of the world champions in case methods. But it would be extremely interesting, and probably you haven't thought about it, to write a case study on case studies. To do this re-entry, for example, for this particular method, and I'm sure that this could be an extremely interesting article with a lot of new insights into case study methodology. So I've simply forgot it on my way. So what I would like to do at the end, and Grandam told me it's the end now, it's the differences between classical cybernetics and new cybernetics. Classical cybernetics, and it was in the 50s and 60s, was a transdisciplinary field for natural, technical, social system. Here it's a post-disciplinary field for the science system as a whole at the second order level. Its first classical cybernetics was for steering, controlling of technical, natural, social systems. Here it's steering and navigating through the science landscape. So it's a steering in the sense of navigation, also for quality control of first order science. And since there are so many new fields, it's an innovation engine for first order research. Classical cybernetics, there was an emphasis on information and information technology. Here it's an emphasis on knowledge enhancements, knowledge technologies. Strong forms of control in old cybernetics, weak forms of control, and classical cybernetics was on systems observed. This is on observing systems. Little relevance for self-reflexive research here. Central relevance, observer excluded, observer included. So these are some of the distinctions between old cybernetics and new cybernetics, and thank you for your patience.
Thank you.